Hello, welcome everyone at our second webinar. In this webinar, we would like to discuss with you the impact and opportunities of electrical vehicles in the remanufacturing industry. I would like to introduce our moderator. This is Rajiv Ramchandra. He is the founder of Recreate India Research Institute, and he will be our moderator for today. So please, Rajiv, you can take over.
Thank you, Kim. A very warm welcome to everybody, all our panelists, as well as those participating from all over the world. When Kim and I were talking earlier, she mentioned that there's been a tremendous amount of interest in this webinar, and several hundred folks have signed up, so welcome to everybody. I will be very brief in my opening. I want to do a couple of things right off the bat. I want to frame the webinar in terms of what we're going to cover over the next hour or so, talk about the flow. And as I mentioned, due to the interest that we've had, we will go a little bit longer just so that we make sure we have a rich discussion between the panelists, as well as an opportunity to answer questions that have actually been submitted beforehand, as well as any questions that might emerge as this webinar unfolds. From the standpoint of flow, I want to keep it simple in terms of chronology. We want to think about this from the standpoint of getting a grip or sense of where we are right now and what's happening in the electric vehicle industry, especially at the nexus of that industry with remanufacturing, where we want to be. And there's been a lot of interest in the remanufacturing of batteries, but from the standpoint of long-term sustainability and the transition to a circular economy, it's really important to look at it from the perspective of the entire vehicle and not just the battery packs, although they have gotten a lot of the attention for good reason, which Mike will cover for us. And then lastly, as Kim also mentioned, the webinar will be recorded. So in case you can't stay with us for the whole of it, please be assured that the slides, the recordings, and any other video associated will be available on the REMATEC website. So that being said, it's a privilege for me to be invited back by REMATEC to moderate the second webinar, and an even greater privilege to be able to introduce this very distinguished panel. With us today are Jan Koller, Group Manager of the Fraunhofer Institute for Manufacturing, Engineering, and Automation. Welcome, Jan. Our speaker from representing the industry is Mike Hague-Morgan, co-owner and majority shareholder of Autocraft Solutions Group. Welcome, Mike. Also joining us are Gregor Onimoller, Chair of the Manufacturing and Remanufacturing Technology of the University of Beirut. Welcome, Gregor. And last but not least, a name that probably needs no introduction, Fernand Weiland, the former chairman of APRA Europe, and author of several books in remanufacturing, the most recent being Remanufacturing Components of Electric Vehicles. So welcome, everybody. Thank you for joining us. And Jan, I will pass it off to you for your introductory remarks and to frame the conversation for us today.
So thanks, Rajiv, for the moderation of the session. I just have two little slides I want to show you today. I would like to start the webinar by briefly discussing the transformation of mobility towards e-mobility, and in particular its impact on the European aftermarket. And to achieve, to begin with, the proposed goal of the European Union to be climate neutral in 2050, the emissions in the transport sector must be reduced significantly, since road transport plays an essential role in this context, with around 15% of the total CO2 emissions coming from cars, passenger cars. And therefore, the European Commission attempts to reduce the greenhouse gas emissions by regulating the permitted emissions per kilometer. And by 2035, only new cars and vans with zero CO2 emissions are permitted within the EU. So supported by the direct subsidies and policy approaches, the number of electric vehicles will continue to increase, and in the long term will account for the vast majority of the passenger car fleet. This can also be seen here on the left side of my slide, which shows the forecast of the EU sales at the top from a recent study in 2022 by the European Association of Automotive Suppliers. And according to this study, it's the medium scenario I show you here. Only battery or fuel cell powered cars will be sold in Europe from 2035 onwards. And what's even more interesting is then the EU vehicle fleet composition forecast on the left side, on the bottom of the slide. There you can see that there will be a delayed effect on the composition of the vehicle fleet, with more than 1/3 of which will consist of battery or fuel cell powered vehicles from 2035, and more than half of the market share from 2040. And this change from the ICE, from the internal combustion engine to electric vehicles has also far-reaching consequences, of course, for the European aftermarket in terms of the product portfolio. So on the one hand, some components become obsolete in the future with the disappearance of the combustion engine, and thus come under pressure. And there are, for example, the internal combustion engine itself, including the engine block, the pistons, the camshaft, but also the tank system, the fuel injection system, clutches, and so on. There are also other components which will not vanish in the future, but will be slightly modified, for example, because they fulfill different functions in the future as before, such as the brakes, which then will also recover energy for the electric batteries, and also the thermal management to cool down the high voltage batteries, for example, or the gearbox. And finally, we have there, here it's called the rising stars. Those are new components, first and foremost, the high voltage traction battery, but also the electric motor or power electronics, which are necessary for the electric vehicles. And for those parts, there will be a great demand in the future, also on the aftermarket. And in sum, the forecasts assume that this market potential for just the battery specific electric components will be around 7 billion or up to 7 billion euros in 2040 in Europe. And if we break down the figures as shown here on the left side of the slide, you may notice that more than half of the market potential is accounted for by the traction battery alone. And the reason for this is that on the one hand, the battery is the most expensive component in a battery electric vehicle and accounts for approximately a cost share of 40%. And on the other hand, the service life of a battery system is relatively short. So assuming a technologically progressive development of battery systems, the average useful life might increase up to approximately 12 years in 2030, according to experts, and is therefore relatively low compared to the vehicle in sum. And due to the series and parallel connection of battery cells, it is often only necessary to replace individual cells or modules or to restore the functionality of a battery system. We will hear more about this in Mike's presentation. And all of this favors the future remanufacturing of battery systems. Although I have to admit that at the moment, the majority of the industry is focusing on the material recycling of battery systems. And so there are many questions upcoming. Who will take the opportunities with this increasing aftermarket of battery systems, how to deal with the obstacles and also the risks associated with those battery systems. And I'm looking forward to discuss these issues together with the experts today.
Thank you, Jan. You made my job very easy with those questions because I'm just going to use those for the panel discussion. No, thank you. This is good. And perfect segue into talking about it from the perspective of batteries, which have often seen a lot of the interest. And we have with us Mike Haig-Morgan, who's been at the forefront of this in terms of the execution of it, in talking about it and converting that into a real world solution from a viable business opportunity perspective. So Mike, it would be lovely to hear all the things that you've been up to in the last couple of years, which I'm sure have been amplified by virtue of what's been happening with the climate crisis, with COVID, as well as in the general shift towards moving away from traditional ICE engines. So thank you for joining us, Mike. Take it away.
Thank you very much, Rajiv. And thank you, Jan. You've perfectly set me up with those slides to show why we as a engine remanufacturer had to pivot into the new EV sector or die, frankly. So if I can make the slides work. So I'm assuming you can all see that. If you can't, please shout. Okay, so traditionally we're a engine remanufacturing business that most of you I'm sure will know on the call. 3 sites in the UK. We've actually grown it from 7 million to 71 million per annum turnover over the last 12 years of owning the business since we did the buyout. And it's all great. Doing a super job, lots of fantastic customers, but clearly with a cliff edge coming around 2035 in terms of new vehicle sales, and then not long after a demise because of the combustion engine that Jan just spoke about. For those reasons, for a number of years now, we've been working on EV batteries, and we are going to take you through that today over what we've been doing and why. So just before we move on, in terms of scope, we are a UK-based company, but EV is a great opportunity for us. I've spoken to a few of you individually, particularly at the recent Automechanica show, and we are now setting up in mainland Europe. So you'll see us get new bases in the Netherlands, followed by Norway, Sweden, and somewhere in southern Germany over the next year to 18 months. That's predominantly because EV batteries are difficult to transport and move around. We've got a more mobile local solution, which I'll take you through. In terms of our EV solutions business, it covers a wide spread of all of the components that Jan spoke about at the start on his slide, but my focus really today is around the battery. The reason I'm focusing on the battery is because within a BEV, you typically got 40% of the vehicle value just in the battery itself. And frankly, from an environmental perspective, it's where all of the environmental impact is as well. Once made, as we're sure you all know, batteries in cars are very, very environmentally friendly once you've got them, provided you're feeding it with the right electricity, green electricity. But to get to that point, it does have a significant environmental impact. Therefore, we must avoid having to replace batteries during the warranty or later in life of the vehicle. Otherwise, we are degrading the impact that we've all tried to achieve at the start. So another one that I'm sure most of you will understand, as we're all in remanufacturing on this call, is the hierarchy of waste. Very much drives our business and in particular, it's very suited to electric vehicle batteries. So we're trying to repair, if at all possible, then remanufacture if we can't repair. Anything that we then can't put back in, we're trying to reuse, and there's some great second life opportunities for modules, and only recycle as an absolute last resort. Now, Jan, I think, referred to, and Rajiv referred to earlier about the legislation, and the way most of this is going now is all too many governments and bigger companies are looking at recycling. But recycling is not the most efficient use of our resources. There is a perception that EV batteries cannot be repaired or remanufactured, and hopefully the next few slides I'll persuade you that that is absolutely an incorrect opinion. So this is on a percentage scale. If you look on the left, that's a percent to make a new internal combustion engine in terms of CO2, electricity, and water. If you recycle it, you get some benefit, but if you remanufacture them, and typically at Autocraft, we're recovering 80% of our components through our remanufacturing processes, you're getting a huge saving in all of those environmental impacts. A new EV, recycling is versus new isn't as good as even a combustion engine on comparator. It's close. But actually, if you look at EV Reman on the far right there, the benefits are absolutely massive for remanufacturing of battery packs. Now, Autocraft has now done thousands of packs, which I think is probably more than anyone else I'm aware of. So we have really good data supporting those numbers. So how do we do it? What's the business model? So it's true to say that you cannot reman an EV battery to what I would say is a pure definition of remanufacturing. You cannot bring it back to exactly 100%. But what you can do, and I'll explain it on the next slide with a chart, is you can bring it back to within the original OEM state of health specification for that pack, for that mileage and that age. I think we all need to get our heads around how we're going to define it going forward. And I'd be really keen to have that as part of the debate on this call today. So what we've been doing for a few years now is we've been working with both vehicle manufacturers and battery manufacturers, whoever's carrying that warranty risk, to replace packs with new packs initially. Then phase 2, we're actually replacing modules with new modules. So at least early on, we're starting to collect core, but we're also starting to get experience of doing the work. A number of our programs have now moved into phase 3. So this is where we're using components that we have saved and modules that we've saved from packs, whether it be from failed packs or crash damaged vehicles, and we're putting them in for what we call remanufacturing. As a result, this business model, we now say that we've got the solution to repair, remanufacture, and even service a battery pack. And that if you service a battery pack and you cut out that, what we call that cancerous module that's causing the problem, because usually it is only 1 or 2 modules that cause the problem, before it spreads, if you can identify them, then actually there is a service business model here. Now, I never thought when we looked at this a few years ago that you could service an EV just like you could service a combustion engine, but you can. And here's the reason. So between the 2 green lines on this chart, this is what the predicted life is and of the battery in the vehicle over time. You'll see that there is a percentage and it will degrade. So it'll start off nominally at 100%, and the modules, there will be only a very slight difference between them. But as it grows, as time goes on, it grows that difference between the modules in the pack. Now you'll see the red line, that's a pretty sharp failure within the warranty life. But even the blue, the blue line there, you'll get some batteries which will get used, they'll get used very hard, and they will need to have some form of service or repair done to them in their lifespan before that vehicle is at its true end of life. What our technology does is test the pack very, very accurately. We have a digital twin in a cloud that allows us to analyze exactly where each of the cells and modules in the pack are. And for the packs that can be disassembled at module level, unfortunately not all can, but most can, then we are able to put other modules in, balance those modules, and get that pack back into its predictive life, so back in between those two green lines. That is extremely important for our industry. So in terms of how we do it, we've got a number of offerings, and everything's very mobile at the moment because there's not the economies of scale. So the most mobile is we have a solution of a trailer that will go out to a warehouse or a dealership group that's got 1, 2, or 3 of these batteries, and we will be able to do a triage and some basic repairs, non-invasive repairs. If we need to go into the pack, then we need a different solution. And for that, we have launched this mobile factory. So it's a mobile, completely integrated factory in a container. This was launched only within the last 2 weeks. We've been protecting our IP, developing this in recent years. And the video for this, Kim is kindly putting that on the REMATEC website just after this webinar. So please go and look at it, and we'd really welcome your feedback. We've had some great feedback so far because it's able to do all of the repair very, very safely and accurately in one solution. And we will be deploying this actually starting in the Netherlands next year with a contract that we've secured in that market. So that will be its first opportunity. And we are doing special guided tours of that in the UK. And we will be doing this year if you want to come and visit us, and we'll do the same next year over in the Netherlands. It does around 1,000 packs a year. When volumes increase, and we already have some significant volumes in the UK, we have a fixed solution. This is our fixed solution in Grantham in the UK, and we're already doing 60 packs a week and have been for some time now. So this is some of our technicians working in this facility. You'll see we have 2 stations, lots of safety systems, and our test equipment integrated into it. So nearly at the end of this, conscious that there's a number of people on this call that will be in the traditional motor business. Actually, if you look at the remanufacturing of e-motors, it's not that dissimilar. I think there'll be a lot of people that can do this market, and that's really good for all of us to have continuity here. And power electronics are actually failing at much higher rates than I ever anticipated. And for those of you who are on the call who are interested or involved in power electronics, I can see your business growing quite considerably. So it's very quick. I'm really looking forward to some questions, and I'll now hand back to Rajiv, please.
Thank you, Mike. No, this is great. In fact, we received a bunch of questions from the registrants, and you actually answered a few of them already, especially the question on the remanufacturing of power electronics. So that's quite interesting to hear that you're seeing an increase in that. So maybe we can come back to that in the panel discussion a little bit. So I invite our panelists to turn their cameras on and turn their microphones on so we can get into the discussion. And also please feel welcome to our audience to drop in any questions you might have in the chat. Okay. Gregor, if you're there, your camera, I think, is still off. There we go.
No, it should work.
Okay, great. Well, okay, so welcome everybody back for the panel discussion. What I'd like to kind of cover in the next 40 minutes or so is to look at it from sort of broad categories. And both Jan and Mike, you touched on some of these elements, but to kind of break it up into tranches of discussion, there's obviously the policy or legislation side of things that becomes a driving force or creates the boundary conditions on how the space evolves. There are undoubtedly technology issues that come into the picture, and there are industry and market factors that come into play, especially things like economies of scale, how these products are being perceived in the markets, the penetration of the electric vehicle in the marketplace, and how that nexus kind of comes together in that overall transition that we're seeing. So if I could start maybe with Gregor, if you have any thoughts on either the policy or technology side of things, whether it's looking at it from an infrastructure perspective or broadly from the standpoint of creating enabling conditions so that more of this can happen in a meaningful way?
Yeah, at the moment, some legislations are pretty unclear regarding transport and storage of batteries. And at this point, there's absolutely something to do to make it more easy to remanufacture or even transport batteries around the country. Like Mike already said in his presentation, this is a great obstacle to overcome.
Right. So yeah, I think in one of the conversations I had earlier, one of the points that emerged was that for the transportation of the battery, typically it's done within the envelope of the vehicle. So there's a challenge associated with sort of the battery traveling by itself. Could you elaborate a little bit on that, Mike?
It's the biggest challenge, actually, is the logistics. Just from the presentation I just gave, we've got the technology to remanufacture them. But you've got to get hold of the battery first. So you've got to make sure it's not a red pack. So we have some special ways of transporting red packs that's not included in this yet because of some patents that I haven't yet had clearance on. But it is a real challenge. There's very few logistics operators that will be able to do that. And that's one of the reasons why we've got that mobile triage. So we're having to go out. But if you're having to go out and test one at a time, it's not very cost effective. So we need to get the logistics industry to catch up and educate them and to give them the opportunity to say, no, this is a safe pack, and to prove that it's a safe pack. And we're working on that. But the mobile center that we've got actually came because we've got a number of customers and potential new customers who've been collecting new packs. They've been replacing with new. They've been locally storing these, not able to transport them, and they don't know what to do with them. They have been sending them to Umicore to have them thermally recycled that way because they don't really have a solution. So we've needed to give solutions, and it's been a very dynamic business proposal. We haven't started this 3 or 4 or 5 years ago with this is how we're going to do it. And it regularly has changed, and a lot of it is because of the logistics. It is very difficult, and even within Europe, there are some countries that will treat batteries as waste, even though they are repairable. So there is a big difference within the EU. So it's a real challenge, and if we can't get some logistics partners on board with it, and fairly quickly, we as an industry are going to suffer.
So is the primary challenge associated with legislation being a hindrance or being unclear, or the fact that those who are in the logistics business are just uncertain or uncomfortable with transporting the batteries?
I think legislation is not ready. It's not catching up. Health and safety legislation as well. What level of technician do you really need to remanufacture a pack? It's very clear, all the legislation about high voltage for AC, but for DC, there's a great lack of legislation. In fact, in the UK, we are helping write that legislation for British government with a consortium with some universities, because it just isn't there. And it's the same for logistics. There is some consumer electronics packs that we've, from your battery, from your laptop, etc. There's some laws around that and how to transport it, but they're not really fit for purpose for something that's as big and as high voltage as an electric vehicle pack.
Got it. No, that's great. That's helpful to know. And I think therein lies the opportunity. And I think part of what we're trying to tease out with this conversation also is to present a current state view on what's happening, but also where there might be opportunities to work together to kind of iron out some of those issues. There's sorry, go ahead.
Rajiv, I have to agree with Mike about also the base status. So once some used product becomes waste once, it's very difficult to get it back to a status of a useful product, or even as a core to remanufacture it. and therefore it's also quite difficult to transport those cores throughout Europe or even other countries.
Mm-hmm. Yep. So Jan, let me stay with you. I was actually going to come to you anyway. There's a question that came in for you, which says, how are you evaluating the failure rates for new products like e-motors and power electronics? And the reason I picked that question also is to kind of zoom out the conversation a little bit, not just focusing on the batteries, which I agree are important, but to look at the overall vehicle and look at the opportunity for remanufacturing of other components and the vehicle in its entirety.
I think that's a real interesting question, because if you don't have the data available about the products in use, they just get into the use phase now. It's quite difficult to have a prognosis of the remanufacturing market potential. But I think you can make estimations, for example, from the research activities we're doing right now. So we have their life cycle tests and can stress, for example, the batteries or the motors, and see how they do with those tests, how they behave, and what is the predicted useful life. But of course, also with the numbers I showed previously, it's quite difficult to have an exact amount, and that's why we're also just estimations. And as you have seen, also the estimations on the aftermarket, it was like between 6 and 7 billions. Could also be more than that. And so that's quite a difficult task to do with those new products arriving now.
Great. No, thank you. With the, as Mike, you mentioned at the beginning, it's, switching to electric vehicles is just part of it, which is to say that if we're looking at it from the perspective of the climate crisis and the elimination of carbon emissions, the source of fuel matters no matter what, whether it's an IC engine or how you're producing the electricity in the first place for the charging. And this is a question for any of you that might wish to answer on the bigger sort of infrastructure side of things, right? So if we're projected to see a growth, as Jan pointed out in his slides, from the standpoint of the adoption and penetration of electric vehicles, that's going to clearly put an increased burden from the standpoint of energy requirements on the grid, assuming that that's kind of the source of energy. What are you seeing? What are your thoughts in terms of the adaptation at a broader infrastructure level, so that this increased requirement for charging is accommodated within the overall grid infrastructure? Any thoughts there?
It's extremely fragmented. We're seeing, even within countries, we're seeing certain regions adopt it much better than others. We're seeing a great lack of standardization, which is worse in the UK compared with the EU. I know the EU have got some standardization projects around chargers and around the sockets, so there's some commonization they're trying to put through there. But it really is patchy, and it depends where you live. And certainly within the UK, you've got a lot of people that don't have driveways. So we're talking on-street parking. So we're talking the biggest infrastructure change that most of Western Europe has seen since the Industrial Revolution, just to get the charging into place. So personally, do I think we'll achieve the level of 2035 and BEV 100%? No, I don't think we will. I'd like to see it, because I think we all need it, but I think there's a long way to go, and unless we can get that infrastructure piece sorted, I think we'll fall short.
Yeah, also adding to the infrastructure, I think it's not just about the electricity, but also about the workshops, the garages. There's a lack of training, and also the infrastructure to handle those high voltage batteries, for example. So there's also a high demand for training, for example, and to get the infrastructure working there.
Correct. And when you get to see the video that we've done of our mobile solution, whether it be a mobile solution or the fixed workshop, we've got all of the camera controls, we've got LiDAR, we've got some amazing technology to try and keep people as safe as you possibly can be. And we're actually doing this on a different basis now for Autocraft. So we can't do every single factory around the world, but we can provide that to others. So it's a bit like the McDonald's model. So in order to try and upscale this as quickly as possible, people will be able to rent these facilities from us. So you can rent it and operate it yourself, or you could also get Autocraft to put a facility in for you, and we'll run it for you. So, but it is far more garage based, as you say. It can't be on. I don't think we're going to get the logistics problem completely resolved like we did on combustion engines, in terms of being able to transport everything back and have big factories doing lots of engine remanufacture. I think it's going to be more localized repairs. And I also think if you look at the data that we see on some of our fleets, so we've got some fleet customers who have put over 100,000, 150,000 kilometers on battery packs. The failure rates at that point are huge. So whereas an internal combustion engine, I always work at about 0.5% of the vehicle park maximum ever needing to be replaced. Batteries, I think you're going to be up at 80 or 90% of them needing some kind of a service and a few modules replaced. Otherwise, your range will diminish to a point that you're replacing that pack within 15 years of the life of the vehicle, which is incredibly environmentally damaging. So it's going to be an absolutely massive multi-billion-pound market.
In my point of view, the infrastructure for the charging stations in Germany and in the EU is looking pretty good. And I think the growing of the infrastructure and the size of the EVs are pretty parallel. So it should work out. But on the other side, like Mike and Jan already mentioned, the service stations are not really prepared for the battery dangers and the repairing at the moment. And there are many uncertainties that have to be addressed at the moment to make this work.
Yeah, thank you, Gregor and Mike. No, that's very helpful to understand. The question came in just building on this issue about energy, and just to briefly play devil's advocate. One of the questions talks about the possibilities associated with hydrogen-based mobility options, and how are you seeing that kind of factor into the overall evolution of the mobility space and its connectivity to being able to be remanufactured, for example? And that's an open question for whoever wants to take it.
We have a number of people in our team with a lot of hydrogen experience. In fact, some of our testing has come from that sector, and we've adapted it for EV batteries. I look at transportation and electric batteries a bit like music. So you started with vinyl records, you went to cassettes, DVDs, and now it's solid state. I think we've started at steam. Or horses, however far back you want to go. Then internal combustion engine has been everything for a long time. I actually think that lithium-ion batteries are only there for a period. That they're the VHS cassette of our period, and we will end up moving to greener technology, hopefully sooner rather than later. Because I don't think EV batteries are as green as we'd really like them to be. The way they're mined, the amount of water to extract the lithium and some of the chemicals in the first place. Hydrogen, if we can do hydrogen properly, and it's some look at Japan, look at what they've been doing, investing in hydrogen, and you look at the architecture of their vehicles that they've now launched. It's quite clear that they are looking longer term. And I think they're looking that they will have actually replace, within a hybrid, they will replace the engine, the combustion engine with a hydrogen engine before anybody else. But again, it's infrastructure. So our industry is not what's holding up the electrical vehicle or net zero revolution. I think it's infrastructure. But if you're on an infrastructure call, they'll say we're at fault. We've just got to work together and faster to get these solutions in place.
Yes, I also think that the fuel cell could be an alternative, for example, for trucks. And we're also looking into the remanufacturing of fuel cells from a research point of view, because that's also a very new topic. And there we also need some more data, and also the innovation cycles are very short in this area. That's just in the beginning.
Yeah. I also think hydrogen will play an important role in the near future to use the excess energy we produce with our electricity. And otherwise, in the near future, the lithium-ion battery will succeed. But later on, then there will be more development. Maybe the hydrogen cell will be on top of that.
Mm-hmm.
It all depends for me. Hydrogen for bigger vehicles, absolutely agree. For the smaller vehicles, you are seeing some really interesting solid state technology at lab scale. It's whether or when and how cost effective it is to upscale that to replace the actual lithium-ion batteries themselves. But we're already committed. For the next 7 years, every vehicle program is already on the drawing board, committed to. You can't change direction quickly. So if it takes, even if we could get solid state batteries or hydrogen within 5 years to be more viable for passenger cars, that's still 5 plus 7, so 13 years from now, before you'll start to see them in any production vehicles in any decent volume.
Got it.
So lithium ions here, we need to be able to remanufacture it and make it as environmentally sustainable as possible.
Yeah, no, thanks, Mike. I think your comments are some of the first that I've heard, and I'm not from this industry, so I might be just very late into this conversation. But to your analogy of looking at lithium-ion batteries as it's almost a transition technology. You're not necessarily seeing it as the end state, and that there's more evolution to be expected or already happening, but maybe hasn't made its way to the markets in a way that's cost effective and viable, looking at all the pieces like legislation and infrastructure.
Correct.
Yep. Okay. Yeah, no, that's really interesting to know, because I think a lot of the conversation has focused on the battery side of things and lithium-ion batteries in particular. And to your point, sometimes there's the danger of the fixating on trying to solve one problem, but not looking at the other issues that come into the picture across the life cycle, like you talked about the mining of the materials associated with battery packs. So really key point there to think about this from a life cycle design perspective. And life cycle costing certainly comes into the picture, because that factors into the economics and the market viability in the short, medium, and long term.
And it's down to us to educate vehicle manufacturers as well. They themselves don't have enough experts in remanufacturing. They started with some manufacturers designing packs which were really, really easy to remanufacture. The Nissan Leaf, for example, fantastically easy. As we're getting to more power density and we're adding active cooling, it gets more and more difficult. But so long as you can take them apart, at least at a module level, you can do really good remanufacturing, and there's real value in that for the vehicle manufacturers. But when they designed these, many of them thought they weren't going to fail, that this were a sealed unit for life. They filled them with foam or glue, so you can't replace modules. And frankly, they're now paying the price, because those that did make it remanufacturable are saving on their warranty compared with the other vehicle manufacturers. I can make these statements because I've got lots of customers in this market and I see it all. I can't say who because of the NDAs, but this is why you're seeing a number of them either stay with or migrate to at least being able to do modules and be able to repair a module. There are some people still looking at cell to pack, because that's actually very often the cheapest way. So no modules at all. I think they're going to have major problems servicing, and the overall cost of their vehicle and the environmental impact will be a lot more than those manufacturers that have designed it with modules to be able to be replaced.
Yeah, I have to approve that statement. At the moment in my research, we are disassembling EV batteries to the cell level, because we want to try to exchange the cells and not the modules, because the faulty modules are often caused by one cell, and
Correct.
the cells are at the moment they are glued in the module and they are welded in, so it's very complex to remove them, and with the welding and the gluing, it's also more dangerous to work on these electric batteries.
And it's not just batteries that have a problem with gluing. So if you look at the power electronics, very often they are large parts of them have got this resin glue bond holding everything together. If a component within that part of it fails, there is nothing that you can do to repair it. So it really depends on power electronics where they fail. If it fails outside of that, then I think it's a great market, but not if it's within the resin. And electronics, I'm seeing much larger failure rates, because power electronics are not new. But if you're trying to lightweight them to put them in a car, you're going on minimal amounts of solder, and you're trying to go the smallest possible level of components. And we are seeing fatigue and burnout at much higher rates than ever thought. So great news if you're into remanufacturing of power electronics, guys. Not great for the environment.
Yeah, no, but thank you for coming. I wanted to kind of come to that, just kind of, going back to zooming out from the batteries, but looking at other components that are part of the vehicle. So, and you kind of answered the question, which was going to be, why are you seeing a greater failure rate in the power electronics? And it sounds like it's associated with some of the design, essentially the design features in the way the materials are being used and being assembled.
Yeah, and I can understand why, particularly if cells are being glued in. It's not just the cheapest way, but if you've got a glue in there, it's absorbing the vibration and it's not fracturing the welds. So the cheapest way to make them is cylindrical cells, packed in, welded with laser, but you've got millions of welds, and it only takes one or two of them on one cell to fail, and it takes the whole module and then the pack down. So what they do is, even if they've welded it correctly in the first place, you do get a lot of fatigue, because that vehicle is going down the road and it's vibrating all of the time, and that leads to failures. So they're gluing them in to try and absorb it, basically, but that makes it even less remanufacturable. And it's this constant battle then that we as an industry are going to have about educating, and it's a new technology. Designers will make mistakes. If they didn't make mistakes, then we wouldn't, as an industry, have the opportunities to fix them. So it's that double-edged sword, isn't it? But some packs have very high failure rates, others very low. We're all benchmarking this. Vehicle manufacturers are doing lots of data teardown to see. But whereas the internal combustion engine, you had over 100 years of refining. Even then they'd fail at the end of 100 years. We still made engines with weaknesses. Batteries, it's so new. Power electronics in a vehicle, it's so new. We're going to see these spikes where you are going to get design problems that were never thought about. And we as an industry just need to keep trying to shout probably more than we are today, educate everybody about making them remanufacturable. So if there is a problem, we can then fix them.
Yeah, those are great points. I just want to be mindful of time. We have about 15 or 20 minutes more, just a quick time check. In terms of, for Jan and Gregor, in terms of looking at it from the nexus between that space of research and applied research, which can often be the leading edge, right, from the standpoint of the evolution of technology, things like life cycle impacts or life cycle thinking in the design process have the power or potential to mitigate a lot of what Mike was outlining, right? To kind of think about it from the perspective of long-term thinking over the life cycle of the entire product and what that means to design something that has durability, longevity, disassemblability, essentially, all the pieces needed to be able to give any product multiple life cycles. What are you seeing there in your areas of research or in your interactions with companies? Is that permeating deeper, or is it still incremental and there's an uncertainty associated there?
At the moment, it's more like Mike already said, we are at the start of a new technology and there will be a lot of development. So I think the manufacturers are more concentrated on the manufacturing itself than on the remanufacturing. And so it comes that the processes in the manufacturing are cheap and efficient. Like laser welding it's a pretty easy way to connect the cells in an automated way, and it's cheap. You don't have problems with vibration. And the next thing with molding or the gluing is at the moment you have big problems with the thermal runaway of the cells, and on this way they try to prevent it. And with the start of the technology, I think they also are after the materials, the elements, and so the recycling takes a higher space at the moment, and the OEMs and the recycling industry is more concentrated on getting high qualities of the materials back than the product itself. It will take some time, but it's after we got the technology of more efficient batteries and higher ranges, I think a product placement will be on top.
Yes, and coming back to Gregor's example, I think at the moment it's also much easier for the OEMs to do a recycling of those traction batteries because they lack the infrastructure right now, the logistics, the trainings, and so on. So it's easy for them to get rid of the used batteries in a way, but they don't have to cope or to deal with all those issues we were mentioning. But I think they have to deal with it sometimes. And I think it's just right now, the waste streams are quite small right now coming back from the market. But as I showed in my slides, this will also be much, much higher in the future. And you just lose a lot of valuable materials also with recycling. It's also not that you can just use the materials and just build up a new battery right out of them. And it's also very energy intensive. So I think that there will also be the transition towards repair and remanufacturing of those batteries.
Yep. No, that's great. No, thank you, Jan and Gregor. I want to talk a little bit about, in terms of the projections, right? That we're expected to see, X percentage of electric vehicles penetrating the market. That's obviously contingent on a variety of factors, as with even being able to remanufacture, but the product being accepted by the markets, it's going to depend on product confidence, infrastructure, pricing, etc. Generally speaking, and this is again for the entire panel, Where are you seeing that from the perspective of consumers, right? So Mike, you'd mentioned that, for example, that there's the batteries in comparison to, say, an ICE engine, the lifespan is significantly lower from the standpoint of the number of kilometers that they run and the need for service and maintenance or replacement. And again, for everybody, how is that being perceived, and what can be done so that these challenges aren't necessarily seen as deterrents from the standpoint of making that buy decision from a consumer's perspective?
I don't think the end consumer really realizes the degradation that they're going to get over time yet. They're being sold a great vision, but they're not seeing the failures that I'm actually seeing at the ground. So I think there will be a disappointment, and they will feel let down once they realize that batteries degrade, and it shouldn't come as a shock. Look at your mobile phone. How good is your battery a year in on your mobile phone, or 2 years in on your laptop? We shouldn't expect lithium-ion batteries just because they're in a car to be, I know the chemistry is slightly different, but essentially it's the same technology. It shouldn't be any different. And when they're making these cars, I don't know whether people are aware, but very often 100%, they don't have it at 100%. So they'll actually overspec the battery and only let you use a certain amount of it. So you've got a buffer. So for the first few years, you won't see any degradation, but there will be degradation. But they're using that spare capacity they built in. It's only when it goes towards the warranty period and out of the warranty period that you start to eat in and you go down that degradation curve. Degradation is unavoidable. And when you then get that and the consumer starts to see it, if they then find out that they cannot remanufacture their pack or have them repaired and it's only a new pack, or they have to write the car off, then the bad press is huge. There's been some very high profile newspaper articles in the UK. There was a Mercedes hybrid, an E-Class estate that made the newspapers here. It was only a mild hybrid, only a small pack, couldn't get a replacement pack for less than £27,000. The car was only worth £17,000. And it was a pack that was this big. And that was a very unhappy person who then went to the newspapers. So I think there's a lot of time to run on this yet, and we've got to be ready for it, because we don't want this technology to fail. Environmentally, we have no option to make the best of it.
Yes, Mike, and I also think that the customers will in the future demand such solutions like a repairman, remanufacturing of the battery, because they won't just buy a new one and put it in their car. So I think there will be a huge demand in the future.
I think it depends on the business model. At the moment, I wouldn't buy an electric car, but there are models with subscription or leasing, and these are totally okay, because you get rid of the car after 3, 4, or 5 years. And so the OEM gets it back and can look at it to see what defaults are. But I wouldn't buy one at the moment. Leasing or a subscription model are fine.
So what we've got in development is a device which will plug into your OBD2 port. It will feed up to the cloud where we have our digital twin. So when it comes to the end of that leasing period, you can actually, as it's going to the auction, it will measure the battery at a cell and module level and give a real state of health. So at least it gives the customers some confidence to know exactly, is the battery okay? Where is it on that curve? And that's something we're launching next year. Without those type of solutions, EV, even leasing a new EV is going to be very difficult, because the residual after 3 or 4 years will be so poor.
but I think those product service system models like leasing and so on could also be a good chance, opportunity for remanufacturers.
Yes.
Because you have this huge fleet which comes back after a time frame, and then you can also look into the battery and remanufacture them.
Correct.
Yeah, you guys essentially read my mind, because that's kind of where I was going with this is, what about the evolution of the business model fundamentally, right? So whether it's a subscription-based model for the entire vehicle, or again, modularity in design where it's the battery that is you're subscribing usage of the battery versus the entire vehicle. And I guess I don't know either way whether, which of those are in play or executable, but there's certainly an opportunity there, at least from a high level perspective, especially from when you look at it from the standpoint of re-engineering the overall industrial economic system to be circular. And so, the issue of reverse logistics, of ownership of the materials, there can be potentially a more elegant solution if we're looking at it from the perspective of purchasing mobility versus purchasing the vehicle, right? The service as opposed to the product.
I think you make a really important point where actually you're touching on something which we haven't yet mentioned, and that's what do we do with the modules and cells that we cannot put back into a vehicle? Yeah. Well, actually only 9% of our modules that we replace go for recycling. Everything else at the moment has been going for second life applications. So we're actually selling these at very high values into grid balancing, solar power backup, power walls, road chargers actually. So if you've got a duty cycle which is less than that of a vehicle in terms of the C rating you need, you can actually repurpose them. Even the worst cells were mostly able to repurpose. It's only the absolute real completely thermally degraded cells that have had a complete chemical breakdown that we're actually having to truly recycle. And if you then take that on to say, well, actually, it's got a life beyond vehicle. So why are you trying to recover the money of that battery on a new vehicle immediately? Why don't somebody own that battery separate from the vehicle? So you lease your car and you pay somebody else to lease the battery. And when you finish with that battery, they lease that into a second life application or sell it into a second life application. There's a brilliant leasing model there. The problem that we have, and we need to educate politicians fairly quickly, is that is much better environmentally to have that model instead of taking batteries and recycling them. Frankly, I think it's the easy, lazy way of doing it. But there's a big report that I read the other day that's come out with a lot of big companies backing it, pushing politicians to have these recycling targets within a vehicle. And if you're writing that legislation without the knowledge of remanufacturing, I totally understand why you'd come to that conclusion. We as a remanufacturing industry need to be doing more to educate to avoid that from happening. So anybody in this call who's got political contacts, in industry contacts, where you can really sing about the fact that we can remanufacture batteries and that second life is a much better way than having to purely recycle, please do so, because we're wasting huge amounts of CO2, electricity and water if we don't do it.
Great. No, excellent point, Mike. Okay, so we are at 5 minutes past. I want to now invite, well, thank you, Mike, Jan, and Gregor for this very interesting conversation. I have a feeling we could have probably gone on a little bit longer because there's so many things to quote unquote unpack, right? And I think that's what's exciting, is that we're identifying not just what the obstacles are, but then potentially flipping it over and saying, well, this is also where the focus needs to be, whether it's in the space of legislation or technology. And I think that's exciting. I really see this as a team sport, right? We can't do this individually or within the tranches of our particular vocations, but really have to work together to find solutions that that work for everybody in the long term. So thank you for this very insightful conversation. Fernand, thank you again for joining us. You've had so much experience in this industry, and also have had the opportunity to hear us ramble on for the last hour. So it would be wonderful if you could share your thoughts and your perspective on how this overall narrative is unfolding, you know, at the nexus of remanufacturing and electric vehicles.
Okay, thank you, Rajiv. I was supposed to talk at the end. That's the reason why I was so quiet. But during this meeting, I made a lot of little notes, which I want to share with you. First of all, I'm talking on behalf of, may I say, traditional remanufacturer who will be faced with these new technologies in the future. So I don't want to be an alarmist, but I have to tell these guys, I mean, traditional manufacturers, that this is a paradigm change for the whole industry, as automotive industry, as we have seen. But it's also for remanufacturers, and they can wait. But I would say they shouldn't be too complacent and start to look at the new technology, because the learning curve, the learning process will be long and difficult. So that's my first point, so you understand where I'm coming from. We have spoken a lot about batteries, and nearly only batteries. That's fine, because as we have seen, the value of the car, the value of the batteries is so big that we have to focus on that. But I have to remind us that there are many other components. You have touched on the power supply. That's a unit which gets very hot, and of course it will fail, and it's failed already. But beside the power supply, there are also other components. We didn't spoke about the problems of the thermal control, the heat of the batteries, the heat of the engine, and all this. And this in the graph I saw with the 6 billion in 2040, I think the thermal side is too low. We are going to see lots of problems. Coming back to the batteries, yes, the batteries for the next 5 or 10 years, maybe not the electrical motor, but the batteries, as Mike has said so often, will fail, because we have seen the reasons. With any new product, the OEM have always design problems. We as a remanufacturer are fixing very often these design problems, and in remanufacturing. So, but there are so many problems at the beginning. For example, this is only a little example. If you have an accident with such a car, what do? I mean, if you have a serious accident, the battery is now a dangerous item, and an accident can happen tomorrow. Yes, tomorrow. Yes, I'm saying that because it happens to somebody I know quite well, my wife. So that's for example, one reason why batteries in the next 5 years will be important, and the other components sometime later. There's an interesting question I will have for Mike, but later. Let me just continue, which is about. I would be very much interested in the 50 packs you remanufacture every week. What are the reasons for remanufacturing these? And you may not tell us or tell your competition what they are. This is an interesting question, because these batteries are fail. To buy or lease a car, I have bought, or my wife has bought a car. She has bought it and not leased it. But yes, you have a point about after the leasing period, which is a couple of years, the battery needs to be checked. And remanufacturing, we're always talking about remanufacturing, but in fact, what we are doing with the batteries is finding a solution for this difficult logistics and the return of calls. We are finding solutions, but checking a battery after an accident or checking a battery after a lease is what the remanufacturer have to do all the time with all the products. And maybe that's one of the most important jobs, at least for the first years coming. Later they will fail and we have to replace Moderator, etc. But these are a beginning. And when we are talking about repurposing the battery for the battery in your house to be connected to your solar panels. For repurposing, it's the same. Before you reuse the batteries, you don't have to remanufacture them necessarily because they may be totally all right, but you need to check them, and that is part of remanufacturing. So yes, guys, for the batteries, there's a big business and maybe earlier business as for the electrical motor, which I mentioned earlier. And I am very pleased to hear all the solutions you have offered. And Mike, yes, Mike, you did a good job, not only at this webinar, but in total. And Mike is, and you should know this, Mike is one of the leaders in this area. And other remanufacturers will follow, but as we have seen, it is a very challenging job. But fortunately, there is not only the battery on these cars, there are lots of other items which remanufacturer will enjoy the business in the future. So that's it for me.
Thank you, Fernand. I think that's a very, I see it as a very optimistic way to end, which is even though there is this paradigm shift occurring, with all the other components that are part of a vehicle, there's still an industry and business opportunities that will continue to prevail for all the components that are part of the drivetrain and the vehicle at large. So we are at the time to close with just a couple of minutes to go. I want to thank our panelists again for taking the time to join us and to have what I thought was a candid conversation about where some of the challenges are and also what the opportunities look like and what the future holds for us as we navigate to that new reality. Thank you for joining us